It's time, baby. Work hard. Now it gets interesting. Today, we're comparing and ordering rational numbers. Okay. Now, in order to compare and order rational numbers, which includes fractions and decimals, integers don't, okay, but rational numbers do. That's what we're moving towards, right? Since we talked a lot about negative numbers, now we're going to include negative fractions and decimals. It gets a little interesting. Let's start off with example number 1 here. Okay, you can represent all of these numbers on number lines just like we can integers. But if you look here at our number line here, we have 0, right? And instead of it just going 0 to 1 to 2 to 3, we've got the numbers broken up into decimals, right? So you go 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then 0.10. Well, no, just go to one whole, right? So see the number lines broken up into decimals. Now, what we can do with this is actually compare and order decimals by doing this, right? So if I were to plot these two on the number line, first of all, the sentence I'm trying to read here is negative 1.2 is what compared to 0.8, right? So what you need to do is tell me that negative 1.2 is less than 0.8, or you tell me negative 1.2 is greater than 0.8, or you tell me that those are equal, right? So let's go ahead and take a look at the number line first to see where we're at here. First thing I'm going to tell you, if you ever see a negative number and a positive number to be compared, you automatically know the negative number is less because it's smaller than 0. All negative numbers are always going to be smaller than all positive numbers. So we already know right off the bat that negative 1.2 is less than 0.8. I already know that automatically. And we should know that with every single problem we address like that. But let's take a look at the number line just to show exactly why that is. Here is 8/10 on the number line, right? Here's 0, 8/10 is not quite one whole, but it's up there, right? And then down here we've got negative 1.2. We go back to negative 1, and then we go 0.2 more, which would be negative 1.2. And you can clearly see that if this is 0, that this number down here is farther to the left on the number line. And what we know about a number line is whatever's to the left is smaller, and whatever's to the right is bigger. And since this is down here, it's smaller. You can clearly see that on this number line here, which shows us that negative 1.2 is less than 0.8. Okay? And that's how we're going to be approaching it today, right? Whatever's further to the left on the number line is smaller, whatever's further to the right is bigger. Next. Now we've got fractions. Don't worry, because the types of fractions that we're going to be dealing with, remember, every single fraction can be turned into a decimal if you really need to. Here's an example of one where you just can't look at them and determine. So you actually have to have common denominators in order to compare fractions. Have to, or else you can't. You can't just look at these and say, oh, well, yeah, that one's clearly bigger than the other. So what you do is you change the denominator to an equivalent fraction. So since the denominators are 8 and 16, and we've done this quite a bit, what we want to do is create an equivalent fraction where this is also 16. And you get 8 to 16 by just multiplying it by 2, right? Which would give us 16 on the bottom, and then we multiply 2 on the top to keep it equivalent, which would give us 6. So really, negative 3/8 and negative 6/16, same amount, right? They're equivalent fractions. So we're going to use this one instead. So what we would say about these is negative 6/16 is what to negative 5/16? And this is where it gets interesting because this is where the mistake people are going to make a lot. Both numbers are negative. So it's not so easy to just say, well, this one's bigger or this one's smaller, right? Our general intuition tells us that negative 6/16 would be bigger than negative 5/16. So you would say negative 6/16 is greater than, but that's not true. Because remember how negative numbers work. They travel the other way. They look like they're getting bigger, but they're really getting smaller because that's the way the number line works in the negative, right? So if you look at a number line here, if we're at 0 and we start going backwards 16ths, right? We go backwards 1/16, 2/16, 3/16, 4/16, 5/16. Here you see 5/16, and then here you see 6/16, right? Negative 5/16 and negative 6/16. And you can clearly see that negative 6/16 is further to the left on the number line, so it is smaller, which means that this number here is smaller than negative 5/16, right? Negative 3/8 is smaller than negative 5/16. Remember, the really difficult thing about this is the fact that you got to change your thinking. You got to flip it, right? Because negatives are opposites. Let's try another one. We're going to go through a couple of these. Remember, you guys can rewatch this video if you need to, right? How about this one? Right off the bat, I know the answer to this one. I already know that number's bigger because that one's negative. This one's positive. I know positive numbers are always bigger. So the way I would read this, sentence is 3 1/10 is greater than negative 3 7/10. I know this is greater. If there wasn't a negative sign, right, that one would be bigger. But there is, unfortunately, it's a totally different number. So we would say this one is greater, and that's the greater than sign right there. 3.1 is greater than negative 3.7. Ooh, interesting. Don't get tricked. How do you think? Negative 4.5 and negative 4.49. These look really close, and they really are. They're really close numbers. They're both negative. So if I was like looking at them as like positive numbers, I would start and I would look at the ones place, which is a 4. And now I'd move over to the tens place and I would see this one has a 5 and this one has a 4. And I would say, oh, this one's clearly bigger because it has a 5. Remember, these are negative numbers. And with negative numbers, they're the opposite, right? So actually, this one's going to be further away from 0 because it's going to be further down on the number line. So actually, this one is smaller. Remember, that's how negative numbers work. So the way we would say this sentence is negative 4.5 is less than negative 4.49. They are literally 1/100th away from each other. This is negative 4 and 1500ths. This is negative 4 and 4900ths. They're 1/100th away, so close. But this one just edges it out for the smaller number because it's further away from 0 down there towards the bottom. You know what? I don't like fractions, okay? I'm going to turn these into decimals real quick, just like you guys should be able to do now, right? If you don't remember, I'll show you really quick. First of all, I don't really care about the negatives right now. I'm just going to look at the fractions themselves. Okay, the first one here, 7/10. 7 divided by 10. I'm just going to put a decimal after the 7 because I know I'll need it because 10 won't go into 7. But 10 will go into 70 7 times, right? So 70, 0. So this is 0.7. So this is going to be negative 0.7. Okay. Now I'm going to switch this one to a decimal as well. All you got to do is 4 divided by 5. All you're going to do is divide the top number by the bottom number. 5 does not go into 4. That's okay. I'll just put my decimal there. 5 goes into 40. 8 times though, which is 40. And so this one is negative, right? 0.8. Now that they're decimals, I think I can do a little bit better job at comparing these. I didn't have to change the denominators or anything crazy like that. So negative 0.7 and negative 0.8. Now my intuition tells me that 0.8 is bigger. But remember, it's negative. This one's actually bigger because it's further to the right of the number line. It's going to be closer to 0. Right? And this one's going to be further down. So this one's, the way you would read this sentence is actually negative 0.7 is greater than negative 0.8. Or to finish the problem out right here, we would just say that negative 7/10 is greater than negative 4/5. Now, this is where it gets a little bit interesting. You guys might get some problems where you're going to have a decimal and a fraction. And my advice to you, just turn all the fractions into decimals like I just did on the last problem. It's going to be your easiest way. All you got to do is take that number right there and divide it, right? 8 divided by 15. I know I don't have the prettiest handwriting, guys. Just bear with me, all right? And then, so 15 doesn't go into 8. We know that, right? We usually end up having to do this with our problems. 15 will go into 80, and then that's might be a little tricky one. I'm going to try a couple things out. But 15 goes into 85 times. Which, okay, so we've got a negative 0.51 and we've got a negative 0.5. We know this is negative 0.5 something. We're going to keep dividing here to figure this out. That's a 5. We bring down another 0 to keep dividing in. 15 goes into 50 3 times. So you know what? I don't even have to keep going. I'm done there. This is all the calculating I had to do for this problem. So don't tell me these are long problems. That's all I had to do to know the answer to this problem. This is negative 0.53. And this is negative 0.51. I have enough information now. This isn't done, but I don't need to finish it because I have enough information to know which of these is bigger and which of these is smaller. I know that this number is bigger. The negative 0.51 looks smaller, right? But remember, with negative numbers, it's the opposite. So this one's actually bigger than this one right here, and I already know that. The negative 0.51 is greater than negative 8/15 because negative 8/15 is the decimals, negative 0.53 something. I don't really care what it is. I already know that it's going to be smaller. So this is going to be my answer to this problem. And they put it on the number line here for you guys so you can see the negative 0.51 is actually bigger. And the negative 0.53 is just a little bit further down, right? What do I got here? A couple left. Let's just do one more. This last one. Order a set of numbers, right? You got to put these in order from least to greatest, right? Smallest to biggest. And that's my favorite way to order them. Sometimes they'll do greatest to least, but let's go least to greatest here. We've got negative 2.46. We've got negative 22 over 25. And we've got negative 2 1/10. Now, with this one, I'm going to do something special here. You can divide these fractions, turn them into decimals. That's what I'm going to do. First of all, we'll start here with negative 2 1/10. You can divide 1 by 10 pretty easily, but negative 2 1/10 as a decimal, guys, just give you a little secret here, is negative 2 1/10. Okay, you know, if your denominator is a power of 10, you can just write that, whatever the numerator is, in your decimal, right? Negative 2 1/10 is negative 2.1. So we've got these two taken care of. This is negative 2.46. That's already a decimal. Now, this one I got to worry about. I want to turn it into a decimal. Now, you can divide 22 by 25 to figure out what the decimal behind that 2 is. You can do that. Or a great way to turn them, like I just said, is if that denominator is a power of 10, then you already know what your decimal is going to be. So I'm actually going to do that because 25 can be turned into a power of 10 really easily. Watch this. 22 over 25. I can turn that denominator to 100 real quickly, just times 4. And if I times 4 on the top, that's 88. So I know that this one right here is negative 2.88. Now I can put these in order from least to greatest. And remember, negative numbers are opposites. So I'm going to look for the biggest one that looks the biggest. That's actually going to be the smallest, right? Negative 2.46, negative 2.88, negative 2.1. Just put a little 0 on there so they all look the same. And this one clearly looks like it's the biggest, which means in terms of negatives, it's going to be the smallest. So negative 2.88 is my smallest number. Now these next two, this one looks bigger, right? Because it's 2.4, this one's 2.1. It looks bigger, but remember, in terms of negatives, it's going to be smaller. Negative 2.46 goes here, and negative 2.1 goes here. And there's my answer. Okay, so I want you guys to see, look at this. This is not that much work. We just need to know how to do it, right? If you have questions, you can always rewatch this video. Remember, I'm in class there too. I can help answer questions you have, but I need you to try, right? You got to come to me with some effort first. And then I got your back. Peace out, guys.